Okay, so here for this question, we want to find the net flux coming out of the box, out of the closed surface. So the flux that goes through these four surfaces here is actually 0, and the reason is that the flux is equal to E dot D of A, and as you can see here, the surface vector is like, for all of them, are like these and these and these. So they are perpendicular to the electric field. In order for them to have an actual number, they need to be parallel to the electric field, the vectors. So the only two surfaces that actually have a flux is this one and this one. And some flux is coming in from this surface, and the rest are coming out from the other surface. So in order to find that, we need to, let's just say this is flux 2 and this is flux 1. So in order to find the net electric flux leaving the closed surface, we need to calculate flux 2 minus flux 1. And in order to do that, we can just like go ahead and say E dot E1 dot D of A. I'm not gonna say different D of A because the A's are actually the same. So I'm not gonna put 1 or 2 here. E2 dot D of A. And we don't actually need an integral here because we have this, and this is the electric field is not based on the surface. Like, it doesn't change throughout the surface, it changes throughout the x-axis, which doesn't interfere with the surface. So I'm just gonna put E1A, which is equal to here A squared or B squared, they're both the same size, and E2 minus B squared. And for that, we can say A squared times E1 minus E2. Okay, so what is our E1? Here we know how to calculate E. So E is actually 2.89 plus a 1.82 x squared I hat Newton per coulomb. So for E1, we know that x is actually equal to a, because for E1 it's at this position. And for E2, we know that x is equal, the x here is equal to a plus c. So I'm just gonna plug everything in. So it's gonna be a squared. I'm just gonna plug a later because the numbers are different for each person. So I'm just gonna plug the rest in. 2.89 plus 1.82, and this one is a squared, minus 2.89 minus 1.82, a plus c squared. So now these two cancel each other and you just plug a in and you get the answer. And the next question is that what is the net charge enclosed by the surface? So in order to find that one is pretty like easier than the first part. So we know that the flux is equal to E integral of E dot D of A, which is equal to Q over epsilon 0. So you just basically need to find over the flux, epsilon 0 times the flux is equal to the Q enclosed by the surface. And this is the formula for the second part. Thanks for being with me.